Interactive flying program. These programs are conducted 3 times a week, Sundays, Tuesdays and Thursdays, 1 o'clock, where a military aeroplane will be displayed for you. Museum has 4 airworthy aeroplanes, Mustang, a Harvard, a Winjeel and a Sopwith Pup. We also have quite a few visiting aeroplanes participate in the program. The aeroplane that's going to be displayed for you today is an Australian built basic trainer from the 1950s, Commonwealth Aircraft Corporation Winjeel. And our demonstration pilot is the museum's operations officer, Flight Lieutenant Dennis Tan.
Squadron Leader Dennis Tan. So the aeroplane I'm going to fly is the Winjeel. Now, just you've got a little handout there, but the Winjeel went out of service around about 1975. So it was used from the mid-50s to 1975 for basic training here at Point Cook. Now, when I did my basic flying training here at Point Cook, which was around about 1990, we flew the CT4, and that aeroplane's on display in there. I think it was number 27, and I'm sure I've thrown up in that sometime. But when you think about this this flight line here, it was just rows. I found a photo in my photo album the other day. There were sort of like 25 CT4s parked there, and there would have been a similar number of Winjeels. And Point Cook's certainly seen busier times in its past, and it's all a bit of a quiet little base now, and it's going to get even quieter as the Officer Training School moves out. It's rumoured to be doing that in the next few years and moving up to Sale, and I don't think that's all been confirmed, but that's what we hear in the streets. So, so as to a little bit of my background, I came out of the roulettes, the RAAF roulettes display team, flying the PC-9 before here. And I've got about 2,500 hours on the PC-9, so it's quite. I'm quite comfortable in that aeroplane. And jumping in this aeroplane is somewhat different. It performs very similarly to the CT4. CT4 is about half the horsepower, but half the weight. So they do about the same job, but this one makes a hell of a lot more noise and carry on for what it achieves. But an absolutely beautiful aeroplane to fly. 2 major differences to the CT4, and there's many other differences, but 2 major differences are the fact that on the front we've got a radial engine, and for those uninitiated in the ways of aviation, a radial engine, pretty much the big advantage as far as I'm concerned is it sounds so nice. And when I fly today, I hope you'll sort of appreciate that kind of sound. It's a much more sort of throbbing sound, and I say the bikies that always seem to turn up here, you know, it's a bit like a Harley, and some of them like that comment and some of them don't. But it's a beautiful sounding engine, and as I taxi towards you, you'll see the cylinders, 9 cylinders arranged in a radial pattern like the spokes around a wheel. The other major difference, and this makes me operate the airplane much differently, is the fact that this airplane has a tail wheel. Now, the CT4 and most modern training airplanes have nose wheels, and if you see those the Cessnas over there, you know, the ones sort of flying in all around the place, they've got a tricycle undercarriage. In other words, they've got a nose wheel and the 2 main wheels. All earlier aeroplanes had sort of tail wheels, and probably the major advantage of a tail wheel is its ease of engineering. It's a stronger kind of system, and so all those earlier aeroplanes had them. The big downside of them, of course, is they're much more difficult to handle on the ground. So ground handling, the taxiing to the point that you can take off, and the point, you know, landing and taxiing out, they are the times where ground handling in these tailwheel airplanes is quite difficult. And the worst possible case is what's called a ground loop, and that's basically when you think of where all the sort of the centre of gravity and the pivot point are, they're all about the same place. So the aeroplane kind of wants to spin in random directions sometimes, and hopefully we'll avoid doing that today. So they're new things for me to handle with this aeroplane. Let me just give you a quick lesson on flying controls, and then I'll get going today. What I'm going to do is taxi down this way. I'll take off in this direction, which is into wind, and I'll give you a quick aerobatics demonstration, and I'll just describe quickly to you how I'm going to do that, and just explain some of the basic flight controls on an aeroplane. So this is called the elevator, and the elevator is used for pitching the aeroplane. In other words, we use it for flying up and flying down. The way I operate that from within the aircraft is if I pull back on the control column, the elevator presents itself like that, and if I push forward, the elevator presents itself like that. So if I pull back, the aeroplane will fly up and the houses will get smaller. So that's, there we go, a bit of revision. If I want to fly a loop, for example, I would simply pull back on the control column and hold it back there. The aeroplane would pitch up and would continue to do so until it completed the loop. Okay, so it's as simple as that, I guess. This control surface here is called the rudder. And the rudder is controlled from within the cockpit using the rudder pedals. Okay, so sort of like the pedals in a car. And I suppose if you were going to turn an aeroplane, it's something like operating a billy cart. Except when you really think about a billy cart, if you push your left foot forward, the billy cart would turn to the right. In an aeroplane, left foot turns the aeroplane left, right foot turns the aeroplane right. And that's used for steering the aeroplane on the ground as well. So all the steering is done with your rudder pedals. So that's one way of turning the aeroplane, and the correct term we use for that in aviation is yawing the aeroplane. But when an aeroplane turns, it doesn't turn flatly, and in fact on a flat plane, and that's very similar to if we're riding a bike or we're riding a motorbike. When we go around a corner in an aeroplane, we bank the aeroplane as well. Okay, and the way that we bank the aeroplane is with the use of aileron. Now the ailerons are once again operated by that single control column. You might be able to see that moving left and right there. So if I want to roll the aeroplane to the right, I would put the right aileron in. This aileron would move up. The one on the other side moves down. Now you can probably imagine the airflow coming along here and striking that surface and pushing that wing down. We could get into more complex discussions about how it creates lift on the wings and all that kind of thing. But that wing would move down. The other one, where the aileron had moved the other direction, would move up, and that would be banking the aeroplane or rolling the aeroplane to the right. So when we're going to fly another manoeuvre that you'll see today is an aileron roll, and the aeroplane just simply rolls around its longitudinal axis. Simply what I'm doing is putting in fact I'll be doing a left aileron roll, putting in the control column all the way to the left, and the aeroplane will just revolve around its axis until it finishes that, and then if I've got everything right, I'll centralise the control column again and off we'll fly. Another thing that tends to occur for this aeroplane is that it can fly inverted, and it can fly the right way up, obviously enough, but it can't do anything in between. So if there's any ambiguity, and during an aileron roll, the aeroplane doesn't really know whether it's inverted or the right way up. And the problem with that is that the fuel system will supply fuel inverted, and it'll supply it when it's the right way up, but it won't do anything in between because there's a little sort of shuttle valve that goes back and forwards. So sometimes you'll hear the engine cough and splutter, and it only happens for a millisecond, but it always seems like it happens for about half an hour to me. So when I'm sort of in that sort of semi-inverted kind of flight, you might hear the engine cough and splutter, and that's what it's doing there. Okay, so essentially explain the three primary flight controls in the aeroplane, and every aeroplane pretty much works the same way. So if we're talking about a 747, that operates in the same kind of way. When you get into something like an F-18, things work a little bit differently, which is a much more complex discussion which we can have later. But anyway, that's the basic flight controls. I hope you paid attention, because I'm now going to select one of you randomly to come flying with me. Just kidding. All the hands go up. All right. As I said, I'm going to jump in, hand you back to Jeff now. I'll get going, and just a short handling display, as I said, aerobatics display. And when I come back, if you've got any questions, I'll be happy to answer them, or attempt to answer them anyway. Okay? So I hope you enjoy the show. Thanks.
Thank you.
Thanks, Dennis.
Well, Dennis has flown this aeroplane earlier this morning, but he'll still have to run through all his cockpit drills, warm the engine up, the oil temperature, cylinder head temperature up to the right values, exercise the propeller, do a magneto check, all those things. We've got two other aircraft around at the moment. We've got a Warrior over here somewhere, and I think the Cessna 337 has gone back to Essendon. We don't have air traffic control here at Point Cook. There's not enough movements here to justify air traffic control. I hear a helicopter too.
Yeah, I was going to say, I'll put
The airfield's in what's called the mandatory broadcast zone. Yes, there it is up there. The Parvic
Helicopter Parvic RAAF is joining crosswind, runway 17 on descent to 800 feet.
We've got a mandatory broadcast zone here. You must have radio equipment in your aeroplane. Pilots broadcast their intention to provide their own separation. We close the airspace for about 10 minutes. Clear! When we're doing these displays, because our aircraft will be manoeuvring out of the normal traffic pattern. Most of its operating life, Point Cook Airfield's been used in a training role. The last Air Force training unit to operate here was number 1 Flying Training School, which disbanded back in 1992. Major users of the airfield now are the museum, RMIT Flight Training, Point Cook Flying Club, various private operators, and we get a lot of transient traffic here from Essendon and Moorabbin coming over to do circuit work. The helicopter down there is, I'll just wait a moment. Full power, you'll see the tail come up at about 40 knots. He'll lift off at about between 60 and 70, climb away at about 80-85 knots.
Sitting up here in the Winjeel at 2,000 feet just above the aerodrome now. If you look out to your right hand side, just next to the control tower, you might see the aircraft. And commencing my run in now. My first pass is going to be coming past you as fast as this airplane can go at about 200 knots, which is close to 400 kilometres an hour. So out of 2,000 feet now and accelerating to 120 knots.
And we always quote aircraft speeds in knots, not
So 1,500, that's 160.
If you want to convert that to kilometres, roughly double it.
Passing through 1,000 and passing through 180 knots, and just over 200 knots now as our pass value at 200 feet. Down to 500 feet and pulling up. 3G as I pull up here and over the top and around about 1,500 feet. And coming out of the loop, holding the control column back, holding out 500 feet again now, and back to about 160 knots. Okay, 150 knots, pulling up. Rolling. Through the diverted there. And back out the other side, back down to 500 feet once again.
Always does the manoeuvre with the nose pointing upwards to start.
And checking the aircraft there, and full left aileron as I roll around the horizon. Got a final pass here to say goodbye. It's just got to go away in position for landing. I'll be back with you shortly. All stations, Point Cook, Heritage Winjeel, display complete, and just tracking now for dead side runway 17, positioning for a left base runway 17 to land. Heritage Winjeel, Point Cook.
Next radio call you'll hear will be low left base, runway 17 graph.
And passing through 200 feet here now. Airspeed's passing back through 75 knots, 100 feet, 50 feet, 40, 30, 20, closing the throttle and looking ahead to the far end of the runway as I raise the aircraft into a 3-point landing attitude. So looking for a touchdown about there, and there we have it. Be with you shortly.
Good view there of the radial engine, so crankcase in the middle, cylinders radiating outwards. 9-cylinder Pratt & Whitney R985, 985 cubic inches, puts out at 450 horsepower. During this display it's only running at about 2000 RPM, constant speed unit, keeps the RPM constant. That shutdown procedure, bring the revs up, quick mag check, propeller into course to purge the oil out of the control system, stop the engine by putting the mixture control into idle cut-off, stops the carburetor from supplying fuel, engine will stop and you can turn off the ignition and the electrical system.
Very smooth conditions for flying today, just absolutely beautiful and fairly light winds as well. Bad conditions for flying. Sunday we did a fly past over the shrine in St Kilda Road there, and it was very, very hot. It was up sort of around 40 degrees and very windy and turbulent, and just not a pleasurable experience to fly at all. In contrast, today was just lovely. However, you can see the amount of sort of murky weather. So not very good for sightseeing, but very, very nice and smooth for flying and doing aerobatics for you. So thank you for the opportunity. As promised, I know that Jeff's very informative, but if there's anything he missed, then I'd be happy to take any questions that you might have.